Nicole has been a board member with the Grass-Fed Exchange here now for, I think, almost 2 years. I asked her how she wanted to be introduced, and just by the nature of her talk, she kind of identifies herself. But she did want me to let you know that she is an international woman of mystery. Oh, and specifically, she is not from Australia. Thanks, Nicole.
No. Thanks, Pete. Yeah. Excellent. So I am, in fact, a New Zealander. If you're not sure. It's quite amazing. When I look around the room, I see old friends. I see some of the most extraordinary grazers in America. I'm not going to say in the world. You people love to say the World Series and the best in the world. You've got to come play some rugby, play some other sports, try some other things. Just saying. I cannot do what you guys do. You know, you guys graze and manage large-scale landscapes. I'm an agroecologist. I work around the States predominantly, especially since COVID. And this is me when I was 5. I was not born and raised on a ranch. I was a military brat. I spent my time being shuttled from Air Force Base to Air Force Base. This is where I was conceived. Apparently, no, I was conceived in a 1958 Chevrolet, which I'm quite proud of, quite frankly. But yes, so this Air Force Base, people think of New Zealand as clean and green. This is one of the most polluted places in New Zealand. It is full of what we call the forever chemicals, right? So we used to, I'll show you my house. So right, that was where my house was. We were right across from the avgas refueling station. Mum, when she would get really tired, would tell us to go and play out on the airstrip. She's like, just go out and play there. So close enough in our backyard. And we had a drain that ran past the house. And we used to make little boats out of walnuts and spent so much time playing in these drains. And what was coming off into those drains was flame retardants, av fuel wastes, all sorts of stuff. So these areas now are permanently locked off. So that's where the avgas is. These areas are now locked off from human touch at all, right? So they are in a process of being decontaminated. But as a result, my brother has ankylosing spondylitis, which is an inflammatory disease. Look it up, autoimmune, it's not very cool. My youngest brother has Down syndrome, and I just finally got a diagnosis of Hashimoto's disease. So I knew that I had an autoimmune I've known for a long time, but this happened epigenetically. Like, this is part of what my mother was exposed to, and her father before her, who was also in the military. Right? So as human beings right now, right across the planet, we're being exposed to all these chemicals. I was poisoned with paraquat when I was 15 and hospitalized, and when I talk to people who handle paraquat or 2,4-D or Tordon, and they say, I'm fine, I don't have any problems. And I'm like, tell me about your kids. And their kids will have learning disorders, autoimmune, leukemia, autism, you name it. Right? And this is a consequence of the epigenetic expression that's starting to change, right? And there's research coming out about it. But as human beings, we are very slow to react to something that's not an immediate acute poisoning, right? So part of what's happening right now is what is the consequence of the Green Revolution. So I'm not going to go into this. I'm not going to bum you all out. You already know these things, right? So we were promised higher yields, that we were going to remove uncertainty, right? That there wouldn't be any uncertainty in agriculture. We're going to eliminate pests, weeds, and diseases. How's that going, by the way? Excellent. All right. We're going to have more efficient systems. We're going to increase irrigation. We're going to end hunger. Hello. Don't think we're doing very well on that. And farmers will be more profitable. Yay! No. All right. Who's more profitable out of this idea of fitting the world to us? Who's winning the race right now in profits? Lawyers, banks, corporations, the middlemen, right? Pharmaceuticals are definitely winning this race, right? Part of this is a paradigm of I'm going to make the world fit to me, not I'm going to fit to the world. All right, so right now we're seeing things like this, frost damage, killer heat waves, floods, another dust bowl. Flew into Denver a couple of weeks ago and you couldn't tell the difference, like looking at where storm clouds were coming in to the dust I don't know how he landed that plane through those dust storms, right? Did you guys see dust storms in the last 2 years? Yeah, so we're seeing the repeat of dust storms, right? Do you know what this is? It's a meteorological, whatever you call it, thingy, looking at about 10,000 feet over Montana. It's grasshoppers. Billions of grasshoppers, enough that it looked like rain was about to arrive, and everyone's like, yay! No! Grasshoppers, right? So driving around last year, I was on 24 different ranches. I went all the way through Wyoming, Colorado, South Dakota, Montana, anywhere I could get my truck and trailer. And what I saw, it literally felt like the apocalypse. And it's interesting because it felt very similar to what Australia felt like in 2018 before the big fires. Just that sense like something's gonna blow, right? So I want to take you back and look and talk about the Moken people. So they're in the Andaman Sea. They are a nomadic sea people. And before 2004, they were living completely sustained by the sea and the forests. And then we had the 2004 Indian Ocean tsunami. Over 225,000 people died in that event. The Moken were reading the signs. They were listening to what the sea had to say and what the landscapes were saying, what the birds were doing, the dolphins, the fish. And they took for the hills, or they took their boats deeper out to sea. And people were very concerned. You know, these are one of the most, they're an indigenous community that's still living by their indigenous law, right? And people were very concerned that these people would have been wiped off the planet. Only one Moken person died in that event, and that's because he had a disability. Everybody else survived. And when they were asked, how was it that you knew that the tsunami was coming? Because there were Burmese fishermen who were fishing in the same places, and they were all wiped out. They said about the Burmese, they said they only see the squid, they looked at nothing, they don't know how to look. And by being able to read those signs and read those signals, they were given that warning. So part of it is that as Europeans, if you were raised as English as your first language, it's part of how we're raised to see the world, as we see the world as separation. So they did a study looking at people that were raised as English as a first language, or those that were raised with Spanish or Mandarin as their first language, and Japanese too, I think. And they were asked to describe an image, and what they looked at was how people's eyes moved. And if you were raised speaking English, you look at the first thing you see, and what do you see? The squid, right? We see the squid. When people not raised as English as a first language, what they say is, I see a coral reef, I see life, I see different colors, I see the water moving. And when they looked at their eyes, instead of their eyes just going to the squid and maybe we move around a little bit, they scatter their eye movements across the whole image. They take in the whole picture because that's how their language raises them to see it. It's not because of race. It's not because of, it's not necessarily where you were brought up. It's the language that we were raised in. So we are taught that is a table, that is a chair, your name's Joe. All right, and that's what we're taught, and we're taught everything in isolation, and that's how our academic institutes flourish, is how do we know more and more about less and less, instead of how do we understand and feel more and more about more and more, right? So when we change how we look at things, the things that we look at change. I took a chemical agronomist with me to this property. The dairy farmer had been running a regenerative biological system for 16 years, had used no fertilizer in that time, small amounts of biostimulants. His milk production, which is about 480 milk solids per cow per year, New Zealand's average is around 340, right? So significantly more milk production. And I took this agronomist around, and what he said was, I would rate this guy an 11 out of 10 in pasture management. And we were with a journalist, and the journalist said, how do you think he's doing it? And he said, he's mining the fertilizer he applied 16 years ago. There was nothing that I could have done to even have a conversation with this guy to get him to understand what was happening here. When you are in a different paradigm and you see the world as separate, you will never understand where that person's coming from. If you had conversations with neighbors sometimes like that, and you're like, they don't get what I'm doing, right? They literally think I'm crazy. Even though I've got more grass, I've got more water, my cows are healthier, they think you're the crazy one. So recently they solved what they were calling the Viking mystery. So between 985 and 1450, Vikings resided in Greenland when the climate was moderate, right? And with them they brought their traditional clothing and their food. They had no integration with indigenous people, and in fact their priests told them that the indigenous people were heathens, and if they even spoke to them they would go to hell, right? So this idea of world to fit, they were trading walrus ivory to the point where they actually made the walrus extinct after they'd already done that in Iceland. Then a mini ice age hit and they got sick. They got really, really sick. They were cold, right? They're still wearing the same clothing that they had in Europe, right? They were still wearing wool. They would not wear what the indigenous people were wearing. They would not adopt the clothing. And so the average life expectancy dropped to 35, and these communities disappeared without a trace. Like, it's only recently these mysteries been solved. So what happened is, if we try and make the world to fit, instead of asking the question of what is it that this landscape gives to me, there's seals, there's polar bears, there's animals we could have made clothing from and survived that cold temperature, which the Inuit were doing. But no, we ignore what the indigenous people are doing because we know better, because this worked in England or Europe or wherever the Vikings were raiding and raping and pillaging. I don't know. Yeah. So, and Fred said this very beautifully, right? So I like what Voltaire says, that doubt is not a pleasant condition, but certainty is an absurd one. And we live in this world where we're trying to control certainty. We can't do it as producers. You guys know that better than anyone, that there's no such thing as certainty. And you get agronomists that will come in and say, if you put this product on, you're going to grow this much crop. And it's BS. Because they don't know what's going to happen with climate. They don't know what's going to happen with hail or insects or any of that, right? But they have this certainty about them, and it's like we can't live knowing about certainty. We've got to be okay and be adaptive and flexible in our minds so that we can deal with uncertainty, and you know that. So right now we are literally facing the perfect storm. So climate is becoming more variable, more extreme. So the question for all of us is, how do we build more resilience to fluctuations in temperature, frost, water, pests, all of it? What does it look like to have a truly regenerative ranching system? How do we fit to the world? So the world around us is speaking, from soil microbes to plants, from plants to animals, and those animals and plants to us. And the better we can hone our ability to listen, then the better we have in terms of being able to take actions to deal with this. So I said I was on 24 ranches last year. 22 of them had root systems that were about half an inch deep. Half an inch to an inch deep, the rooting systems on these plants. And these are not bad producers, right? Many of these producers have been doing adaptive grazing for 20, 30 years. There's no resilience in that system. So you've got to start to ask the question of, how do I really get a root system that was like what it was like when the colonials first arrived in these landscapes? So we are receiving messages all the time from microbiology. So the odor of the earth itself, so geosmin, which literally translates as the odor of the earth. So that smell on a hot summer's day and you're driving on the road and you smell that smell that hits your nostrils and you're like, wow, who loves that smell? What is that smell, Deborah? Just to the chase. Sex, okay, good, thank you. Bacterial sex, all right? So it's an organism called actinomycetes, and when the water lands on the road, it throws up its spores to celebrate being able to reproduce with that bit of moisture, right? We can smell geosmin at 5 parts per trillion. To put that into perspective, we can smell that at 200,000 times the dilution of what a shark can smell, a drop of blood in an Olympic swimming pool. We are tuned in to smell this smell. And for me, it's because literally this is where we came from. This is the smell of the mother. We all recognize it, even if we live in a city or we live on landscapes all the time. We know the smell of healthy soil. They are looking at extracting a certain type of bacteria from soil that will be a vaccine for people involved in high stress. So first responders, people in the military, as a vaccine against PTSD. It's a soil microbe. The one that Deborah was talking about forms natural antibiotics. We make over 200 different types of antibiotics from the soil, right? The soil is where we originated from. It's where health really lies. So I often think about this, like 8% of our human genome originated from viruses. Those of you that are taking ivermectin, it's an antiviral. Your body is made of viruses. We were meant to have exposure to viruses, right? They're part of how we evolve. They're part of how we adapt. We have more bacterial cells on our body and in our body than we have human cells. I often think about this when I reach for chocolate at like 10 o'clock at night. It is not me, it is my microbes, right? It's true. Or when you need that beer and it's like 4 o'clock. Honey, it's not me, it's my microbes. They really, really need that beer, right? And there's something called the farm effect, which is that early exposure of children to soil, to animals, to plants, inoculates that gut microbiome and sets you up for life. Or disabilities, right? If you don't get exposed to those beneficial microbiology, your gut will never be as healthy as it could have been. Right? And some of those microbes are very specific. You get inoculated very young. The people that breathe on you, so whoever breathes on you first could infect you with strep A or strep B. One of those organisms gives you halitosis and sore throats for the rest of your life, and one of them protects you from sore throats for the rest of your life. You want to know the first person that breathes on you doesn't have halitosis. Just saying, so just check that, okay? And then fungi have a huge role in the evolution of our brains. If you look into the stoned ape idea, that there's this theory that human consciousness took off with the exposure to psilocybin mushrooms. I personally like that one. I think it's very interesting. But we are just barely learning about this new frontier of microbiology. Like, I heard a scientist talk about it like we're standing on the edge of a precipice. And we have just a flashlight that we can shine into the dark, and what we shine on is what we're looking at. But that's all that we can understand with our current science and our current ability to even understand the world. And we know perhaps 1% of 1% of 1% of what's going on in the soil. And the same with our human gut, right? It's really, really exciting time. So I want you to imagine that underneath the soil, there is literally an underground metropolis. You have more livestock underneath the ground than you have above the ground. And these microbes are doing very specific things. I want you to imagine that right now you're under the soil and it's pitch black, right? You can't see anything. But you can sense where food is. It's back there. You can sense where the hot girl is. She's back there, by the way. You can tell that someone's tracking you down and wants to eat you. And you can also recognize where your prey is. A cow pie lands way over there, and you can smell it, right? Rancher Steve just walked in the field, and everyone's like, oh God, Steve's back, right? The microbiology are communicating all the time with all these incredible chemicals and sensors. So I want you to imagine that on every single cell wall, and this doesn't matter if it's bacteria, if it's a cell in your body, has hundreds of thousands of receptors. And what they're saying now is it's literally your cells are the brain of the body. Like what Fred was saying so beautifully is that it's all connected, right? And they're listening for some kind of signal. So it might be a physical sensation, right? It might be sensing each other, vibrations, smells, it might be the temperature, right? So there's 100,000 receptors on the outside of that cell membrane, and what it enables you to do is for that gene to change, not the gene, but the cell itself to change gene expression, or for microbiology to turn on or turn off, okay? So this is the activation of our cellular responses, or how microbiology respond in soils. So the more signaling metabolites, and they could be coming from plants, that could be coming from A cattle beast with her tongue wraps that around a plant and cuts that grass, and she leaves protozoa actually in the saliva on that plant to signal to stimulate more root growth. Right? These signals are happening all the time. We don't even know the names of most of the types of chemical signals that are being released, right? But they're happening all the time. So if you imagine this is a plant, we want some diversity in here, but what you find is the plant is signaling to microbiology. It will release different types of volatile organic compounds. It might connect with mycorrhizae. It's releasing root exudates and saying things like, hey, I really feel like pizza. Has anyone got pizza out there? And they'll literally send out a signal and they'll pay that microbe with the currency of the planet, which is what? Carbon, right? So just as carbon runs our current industrial system, carbon too runs what's happening underground. So they'll pay that microbiology, and in response, those microbes release different types of plant growth promoting hormones and microbial volatile organic compounds, right? So this communication is going on all the time. I often get people asking me, can we do this hydroponically? No, you cannot. That is stupid. Stop it. In fact, it's impossible. Okay, so if we're looking at lifting that nutritional profile of having all of these different types of metabolites and compounds, it happens in relationship with microbiology. Right? That plant doesn't do it alone. Think of all of the systems that plant is actually outsourcing. So its stomach is outside of its body. Its immune system is outside of its body. It can't walk. It needs to be able to do this in relationship with microbiology. Right? I just want to share this example. This was absolutely extraordinary to see. And some of you have been on this property. So Cotopaxi in Colorado, Steve and Nancy Oswald at the Oswald Cattle Company, they did some work with Annie Overland. What you're looking at here is some of their high meadows. They tested them biologically. These meadows were very fungal dominant, right? Beautiful diversity in there. This family is really, really good grazers. Now they had some fields that were called the cheat grass fields. So you can imagine what they look like, right? And no matter what they did in terms of grazing management, grazing impact, they were even trying things like bale grazing, they were not seeing that response. They were not seeing their cheatgrass fields turn into this. Right? So this is an example of what the fields look like. So what you see in the foreground is purslane and cheatgrass. And then in 1 yard square, what they did is they sprayed the equivalent of 35 pounds an acre of a compost extract. It was a high fungal compost extract based on the Johnson-Su process. I also know that we can do this with high fungal vermicast, right? So 35 pounds an acre is an extract. You're talking about 1 drop of compost to 1 drop. We're talking tiny, tiny amounts. What we're seeing is the effect of the metabolites. That microbial communication switches this on. So a cover crop was sown into all of those fields. There was some buckwheat, some sorghum Sudan, vetch, I think, some other species. The only places that plant germinated and grew vigorously was where they had that extract applied. We're switching on the signals for germination. And we've been doing this on rangeland in Montana. And actually, there's some people in the room that have been doing this. Go and talk to them. Small volumes of compost or vermicast extracts to switch on the germination signal for plants that have been dormant in the soil for a long time. Your land is communicating to you about what your past management practices have been. All right? Has this place been overgrazed? Are we still seeing the impacts from the 1930s? Yes. We can still see the impacts from the 1880s in some places in California and down here. You can still see the impacts of your forefathers' fingerprints all over these landscapes, and those lands have never recovered. Right? So the question that I ask is, what is it that's putting a drag on your system currently? And I have a framework that we call the 5 M's. What's happening with your mindset? Is that your number one thing that's putting a drag on success on your property? And if you're not sure, ask your wife, which you might not listen to, right? But maybe ask a friend. Is it me? And quite often what you find is the limiting factor to success is you. Is it your management? Actually, no, I'm doing a great job managing. I'm getting my timing right. I'm allowing plants to fully recover. And by fully recovering, I want you to start digging holes and seeing, are those root systems recovering? Or since you have been managing this land, have those root systems been shrinking? Above ground recovery does not mean below ground recovery. We need to be digging holes and taking a look. Is there a major mineral imbalance that's putting a drag on that system? Have you got a major microbial imbalance? What's been causing that? And asking the questions of why and why and why. Is it low organic matter? And I think for probably 99.9% of you in the room, you've got some issues with organic matter, right? And I'm talking about functional organic matter, that's going through microbiology, that it's active, that a cow pie, when it lands, is gone in a few weeks. We worked on a ranch where they had 700 dung beetles per cow pie. I've got the video, it's incredible. It was terrifying because it sounded like swarms of wasps. The minute that cow pie landed, in came the dung beetles. What does it take to have an ecosystem like that where a cow pie only lasts minutes? Amazing, right? So we ask these questions because the piece that I'm seeing missing is you guys have the mindset, you're here. You have the management, you've probably done decades of grazing management, many of you, but we're missing the nutritional microbial piece and organic matter is not being built. So we know that plants need complete nutrition for defense and health. Do we have the nutrients in the ecosystem? You might have lost 30 to 60% of your organic matter since the 1880s. Some of you are literally ranching on bedrock. In tall grass grazing systems that once had bison and you're on bedrock, we have lost a resource here. On average, Americans lose about 4 tons an acre of topsoil per acre per year, which is about the equivalent of the thickness of a sheet of paper. But you've been dying by 1,000 cuts, right? Because it's going unseen and unaccounted for. And what was lost in that is your trace elements, right? And we're seeing those deficiencies show up. They're in the human population in this country. You guys have no zinc in your food. What does no zinc in your food do? Yeah, you have no immunity. Anyone go and look at statistics on COVID and who got slammed? Hello. You have no natural immunity because we're not getting that, and then you're hungry because you have a hidden hunger, just like the microbiology. There's a hidden hunger that makes people eat more. Like when I first got here and you have steaks like that, I'm like, what the heck is that? As a New Zealander, right? And then your beef, chicken, lamb, pork, all taste the same. It tastes like corn. I was like, what the heck? What are we eating? Just asking, okay. There is a significant breakdown in terms of nutrition in the food that we're eating and that we're producing, right? And calcium, magnesium, many of their trace elements are absolutely critical in that plant communicating to microbiology or defending itself, right? And many plants now through breeding no longer communicate to microbiology at all. There's wheat species that no longer form relationships with mycorrhizae. There's cropping plants that no longer communicate to protozoa or nematodes to say, I'm under attack, can you come and defend me, right? And we've done that through what we're doing with our breeding. So I just wanted to share this example, and I'm actually putting a couple of stories together for ease, right? But what was happening on this ranch is they were losing calves to abortions throughout the growing season, all right? And they were eating ponderosa pine needles. And so just to get a sense of how many needles you need to eat for an abortion, it's about 2.5 pounds, right? Those cows were looking for the needles all through the growing season, and there was grass, right? There was things for them to eat. And then one of the things I noticed, so we turned up at the ranch and I could hear the sound while we're driving through the herd. So I got the rancher to get out and listen. And every single cow in that herd, her joints were clicking. What causes clicking joints? Do you know what it is? Have you ever heard it? You're going to hear it now. You're going to start listening for it, right? It's a boron deficiency, right? We need boron for joint health. If you have even cutting horses or performance horses that have a lot of joint problems, look at boron. What's happening with boron? So we looked at what was happening with boron, and then I tested the ponderosa pine needles and then tested their grass. The boron in the ponderosa pine was twice as high as what it was in the grass. They were looking for boron, and as a consequence, losing their calves. So asking the question of, I wonder why. Why is it that I have this particular disorder? What could it relate to? And I can promise you it's not a deficiency in a chemical from a salesperson. It's not. It's not because you haven't got enough herbicide or a drench, right? There's something else going on. So in humans and animals, we see joint issues. In plants, you'll see hollow stems like this in alfalfa. Alfalfa is the canary in the coal mine. All of your legumes, they will show up boron deficiencies first, and then they will disappear. So if you have very low legume percentages, you don't want to see like 30% legume in your pastures. And if you don't, potentially it could be boron. So boron's the steering wheel. It's what takes minerals and sugars around in the plant. Gary Zimmer said that. I really like it. You may see corrugations, so plants growing kind of zigzag. That could be boron or it could be calcium. But the important piece of this is boron is what translocates and moves sugars around the plant. Why is that important? Why do we want sugar moving around? Because if we don't have sugar being moved around the plant, it won't be moving it down through the soil. You will not be feeding microbiology and you will not be building carbon. We see very poor carbon sequestration on properties that are doing a beautiful job with their grazing, and we do not see carbon being pumped deeper into the soil. Right, so on that image there, we've got our short carbon cycle. So every day the soil breathes in and it breathes out, and it breathes in and it breathes out. All that manure and the litter and urine and all the material trampling, that's the short carbon cycle. It's very important. It stimulates microbiology, but only really in that top part of the soil surface, like in the top 4 inches, right? It's what I call, I'm here for a good time, not a long time, honey cycle, right? And it's important, right? What we want to be doing is pumping carbon down deeper. Anything that gets down below 4 inches has been pumped down there probably by mycorrhizae in relationship with the plant roots. A study done in Oklahoma showed that that carbon down there is anywhere between 500 to 2,000 years old. We want long-term, more permanent carbon sequestration down into the ground, and boron plays a role in this. And I would say probably 80% of ranches I go to, boron is not functioning like it should, not functioning well. The other element that I see that is not working as well as it could is zinc, right? It's absolutely critical for immunity, wound healing. It's what moves vitamin A around, so very important for things like eye health, important in enzymes, protein, DNA, growth and development. For visual signs, you'll see pink eye, pneumonia, foot rot. Cattle that are low in zinc have a bald patch at the top of the clove of the hoof. Take a look. They can also grow longer hair on their top line, and the white hair will grow nearly twice as long. So if you have Herefords, I didn't know you guys, they're Herefords, by the way, but Herefords will have longer white hair. Check it out. We've done hair analysis to take a look at this, and it absolutely lines up. I found a book written in 1880s about these visual indicators. We tracked it doing liver and blood and hair analysis, and those books in the 1880s were absolutely spot on without all the laboratory testing around trace elements and the importance of nutrition, right? Where does zinc come from? Zinc is all about building organic matter and biological activity. Mycorrhizal fungi are the main way that we see zinc being mobilized and brought to the plant. So you imagine plants on the left, or the roots on the left has no mycorrhizae, the roots on the right have mycorrhizal relationships. We are testing rangeland and seeing plants with 0 mycorrhizal colonization. If you find that you're not getting any moisture and suddenly you're in a drought, like in New Zealand in 2 weeks they're in a drought and everyone goes boo-hoo, but like literally they're in a drought within 2 weeks if there's no rain. We have a look, there's no mycorrhizae, there's no resilience, there's no access deeper down for water and nutrients, right? And that's the role of your mycorrhizal fungi. You want to get really interested. What's happened in this ecosystem? What's happened in the past? Why have I undermined this critical relationship with biology? We also need calcium. So calcium for animals. Calcium controls every single cell wall. It's your bones, it's your teeth. We see cattle with osteoporosis. It's what's driving meat and milk production. It's what maintains your blood pH. So animals that have a deficiency in calcium often have some kind of inflammation. And many of you have a lot of calcium. It's just not functional, right? So visual signs, what you'll see are those corrugations on the leaf. You'll see new growth that may be deformed, especially on your legumes. The grasses will feel hard. They're sharp, they're coarse. You try and pull them, they won't snap, right? As we start to lift calcium, you'll see those grasses become soft and palatable. We'll see the domination of our less palatable primitive species like your Japanese brome, your cheatgrass, your Medusa head, ventonata grasses. This is the domain that they want. They want low functional calcium. So many of the weed pressures and what we term rank. Okay? That rank grass, and what's the color of that grass when it lies down? It should keep a really golden color, and what I see is a lot of oxidized grays, blacks, pale color, right? That's an indicator that you don't have functional calcium in those cell walls. The grasses that you want to grow, if you were to test the bricks, the photosynthesis, and compare that from a grass you want to maybe one you don't want, or a weed, what you'll find is the grasses that you want will have a lower bricks, and the ones you don't want will have a higher photosynthesis. So I was interested in this because I was working with this particular dairy farmer who was seeing that he had fields that had very low quality grass, that he would see low bricks, low metabolizable energy, and poor milk production in this case. And as we started to stimulate that soil and lift the available calcium, then what happened was, instead of magnesium pectates, so pectates are what in between the lamina of the leaf, so you can see like what's in between those cell walls are your pectins, all right? It's what keeps stuff green, but it's what gives us quality. It's what improves your bricks. We'll see high metabolizable energy and high animal yield. We measured between different fields. If he was grazing on these fields with the calcium pectate, high bricks, he was earning an additional $3,000 a week when he was producing milk on those fields. All right, so how do we do that? It's all about the fun guys or fun gals. Okay, so fungi are what lift our functional calcium. You can be sitting on limestone and have calcium deficiencies in plants. What they do, and you'll see this if you ever look at, you'll see it even under a microscope. If you look at fungi, you'll see they look rough. There's a texture to them. What they're covered in is calcium oxalate. They increase the availability of that calcium form to the plant. They change that from a magnesium pectate, low quality, to a calcium pectate, high quality. They also release nutrients bound on rocks, and they build rocks, which I always thought was quite amazing, right? So there's different types of rocks that fungi will, in relationship with things like copper, magnesium, calcium, make different forms of rocks. And I want you to look at the chemical structures of that. I didn't do that to look really impressive because I got like all these chemical names. It's like, look at the chemical structure and you will see carbon. You will see carbon in that. And if we're looking at really building carbon for the long term, fungi build rocks. Don't ignore the inorganic carbon test on your soil test. If you're looking at measuring carbon, measure inorganic carbon as well. They're building rock and leaving it there permanently. They also make water, literally. Right, when they break that organic material down, 20% of what they exude is water. They take that carbon to make chitin for their bodies, and they take some of that hydrogen, some of that oxygen, and release water. You can find old accounts of colonials coming through these regions and talking about, like there's one place I can think of just north of Billings. The cavalryman said they never had to go further than 2 miles to water their horses. You go up there now and it's literally like Mars, like well, the apocalypse. I mean, there's no water anywhere, but if you look on satellite images, you'll see there once was running streams. Part of that is the building of fungi. They build that pore space, they're building all that aggregate structure, they're holding on to and releasing water slowly. So if you are not focusing on how do I lift fungi, you're missing the resilience piece. I wanted to show this image because we were out at Deborah's yesterday and I was talking about the Rastafarian roots. So the image on the right-hand side is actually from A.G. Smith, who was in the room. Go and talk to him. He's doing amazing things. You want to see that your roots are covered in this soil material, right? It's the difference between drought. It's the difference between nutrition. It's the difference between you making money and you not making money, right? How do we build that rhizosheath? Okay, so it's defending the plant. It also buffers the plant in pH by as much as 2 units. So you might have a soil of a pH of 9 or a pH of 5. With a rhizosheath, that plant can defend itself. So we're planting seeds into saline areas and getting germination because we're treating that seed with a compost or vermicast extract, and that plant can grow because it develops a rhizosheath like that and it can defend itself. Right? So what are the keys to lifting those plant and biological signals? We want to look at why is the plant not photosynthesizing as well as it could? And I use those 5 M's. Is it me? Is it my management? Right. Do I not have diversity in the system? Am I stressing my plants out just by walking in the field? Do they get stressed out because I'm here? Right. How do we increase diversity? Are we providing diverse foods for microbes? So those trampling, manures, it might be seed dressing, it might be getting into poultry or sheep or something. What kind of diversity will help to stimulate underground diversity? And then if I have any major imbalances, so I'm going to test my leaves. What are my animals experiencing? Can I use my animal to get nutrient around? Can I use animals to get seeds around? Right, and then looking at adopting any practices that are going to build my carbon and build that water holding capacity. So the message from me from this is your land is speaking. Start to observe the patterns all the time. That photo on the right is from yesterday at Deborah Clark's place. What sort of patterns are you seeing? Oh, and Emery too. Sorry, Emery. All right, what kind of plants are growing? What do they have to say about nutrition? What are they telling you about microbial imbalances? They are all telling you something. Dig holes, take a look at the root systems. What are those roots telling you? What kind of roots do you have? How deep are they going? What way are they growing? And ask the question, how do I fit to this world? Am I trying to push a crop or an animal type that maybe is not fit to my landscape? And it's really stressful and it's costing me more money. How do I start to ask the question of what used to be here before? How often were animals even coming through? You know, you think of that big mega herd of bison. Were these landscapes even being grazed every year? And if you look at some of the buffalo jumps, there's places that were only having buffalo jumps that were being used every 5 to 7 years. Does that mean big herds were only there every 5 to 7 years? I don't know. But how subtle can we be? Some of the things that we're doing, we're talking about ounces of applications if we are using applications, and I'm not saying that you should, but what we're finding is there are keys and catalysts that we just need to turn that on and that system comes to life. How little does it take, and how do I build resilience? So to go back to the tsunami, notice what's still standing. So this is the difference between resilience and resistance. Resistance is the stone and mortar, the buildings, the concrete. We have great big steel posts. They all went away. But what stayed and what was resilient were the palm trees, right? So the palm tree was able to do this and then come back. What we have in agriculture is we have a lot of resistance, right? We're going to be strong. We're going to be strong as individuals. We're going to hold our feelings in to the point where we even become numb. And we think that's strong. We're going to have a stiff upper lip and we're not going to talk about things, right? And I deal a lot with this in Australia, right? And I actually said to them that that's not strong, right? That's actually weak. What is strong is that we start to be able to be vulnerable and be able to share about what's happening, be able to talk about what's not working well, what is working well, and talk about our feelings. Because if we don't, and we are resistant and strong, we get to the breaking point. That could be a divorce, that could be losing the ranch, that could be losing your life. So how do we build resilience in the system starts with us, which is what Fred beautifully said, is we need to be starting this conversation with ourselves, right? And so the mentor groups, the Herd Fellows, I think is such a powerful way for us to start to communicate and communicate together as a community. So I want to thank you so much for allowing me to be part of your community, and thanks for listening.